In this question, what we have is a question that asks us to find all real x such that the absolute value of 2x minus 1 is strictly greater than the square root of x times 2 minus x. Now, there are a few different ways we could approach this question. We could potentially approach it by cases. That's one way we would do it. You can potentially do it graphically. That might also help. Neither of those, I think, are particularly enticing here, to be honest. They can be done, and they may be helpful to look at it in different ways, and we could look at that. But I think what we'll do is we'll do it algebraically without cases. And that is actually one way that many people forget. But I actually think that's probably by far the best way to do this particular question, because graphically, you're not going to get an exact answer. It will help you figure out what's going on. Algebraically without cases will probably be the best solution. And cases is just going to be very, very finicky. So what I think I'll do is we'll look at it graphically first to give you some sense of what's going on. But that might be a bit tough depending on how well you know how to graph these things. And the best way really is to do it algebraically without cases. So we really want to be able to graph this, and that probably makes it a bit more difficult, okay? So we'll do a rough graph. I won't do it particularly thorough graph, but we do need to have some idea. So the absolute value of 2x minus 1 is, of course, going to basically be 2x minus 1. So it looks like kind of this straight line. But of course, 2x minus 1 looks like this. But of course, we want to sort of have it bouncing to the other direction when it's negative. So that means we're going to flip it, and it's going to do something like this, approximately, and which means the absolute value of 2x minus 1 is just going to be, well, this section here, when it's positive, and when it's negative, you take this section here. So the black line is y equals absolute value of 2x minus 1, noting, of course, that it's y equals 2x minus 1 in this section. It has an intercept at 1, and it has a y equals, well, negative 2x minus 1 in this section. And that's basically going to be your graph there. Now, this one is a lot tougher to draw. If we consider fx equal what's under the square root, that's going to be, well, x times 2 minus x, which would be negative x squared plus 2x. Or perhaps better to think of it as negative x minus 2 times x. Drawing that means that, just very roughly, it's going to be a parabola, concave down, at 0 and 2. So I'm going to get this sort of shape. So that's basically what we're going to get. And now we want to draw the square root of that. So just a quick practice on your graphing. If you want to square root a graph, then don't worry about the negative. So ignore that, ignore that. The square root of 0 is 0. The square root of 0 is 0. So we know that you're going to go from here to roughly to scale. It will be around here. Okay, it's not entirely to scale. We'll note, of course, that this here is a half. Okay, so we know it crosses those points. We know it goes 1, 1. So the square root of 1 is 1. So to be clear, at x equals a half, this is also equal to 1. So actually, they're going to cross each other at 1, 1. Because the square root of 1 is 1. So we're going to get this sort of curve. That's the kind of idea, okay? The square root of this will not be the same curve, but it will be a sort of more vertical curve and flatter here. That's the kind of gist. So this is represented by the blue curve. This is represented by the black curve. You're trying to solve for this is greater than the blue curve, which really means you can see quite clearly here that by the good fortune of being able to work out the intercept there, we already know that the answer basically is going to be x, this section, which is x is greater than 1. And we're also expecting a section to the left. So x is going to be smaller than some number k. If we don't know what this k is, then we can kind of just take it as, make it a bit simpler. You want this line to intersect with that line. And so in terms of cases, we're taking negative 2x minus 1 equal this, and then we can solve. So let's do that first, and then I'll show you the nice way to do it. So we've got, basically we're trying to find that k by solving for y equals negative 2x minus 1 with y equals the square root of x2 minus x. In other words, negative 2x minus 1 equals the square root of x2 minus x, specifically this case. You're looking for a value. You're not looking for all values. You're actually looking for a value that's between 0 and a half. Okay. And so we'll need to square both sides. And this is where it gets a little bit annoying, but still doable. So 4x squared is going to be minus 4x plus 1 equals x2 minus x, which is 2x minus x squared. Move everything to one side. So that means you've got 5x squared minus 6x plus 1 equals 0. So with that in mind, you can factorize this. 5x minus 1, x minus 1. So we get an answer of x equals 1/5 or x equals 1. Now, x equals 1 is not a solution as far as we're aware. And that's actually because we won't get into the details, but it's because we squared it. Okay. So basically, the x equals 1 is this answer here because it's with a positive one. And because we squared it, you get both. And this one is the 1/5. So your answer is basically x is less than 1/5 or x is greater than 1. And hopefully with a graphing there, rough graph there, that gives you a good idea of what's happening. Now let's imagine we didn't do any of the cases. We didn't do any of the graphing. We have no idea what's going on. And we're just trying to solve this. Okay. So now we have the situation where we've got 2x minus 1 is greater than the square root of x2 minus x. And we have done none of the work beforehand. Well, in cases like this, especially when you've got a square root on the other side and an absolute value on the other side, I think it's very helpful to remember that the square root of y squared is the absolute value of y. We've talked about this before in terms of an easy mistake to make when you've got the square root of y squared and people forget to do the absolute value. But equally useful and equally forgotten by many students is that the square root can be expressed, the absolute value can be expressed as a square root of something squared. So in other words, I'm simply saying I'll immediately change this to the square root of 2x minus 1 all squared. And then immediately the square roots disappear. And then you'll notice the working is quite similar to what we had earlier, but I haven't relied on any prior work at all. Now, this is a concave up quadratic. So you can either pick your favorite method and so forth, but we know your intercepts are 1/5 and 1, and it's concave up. And you want it to be greater than 0. So just solving this quadratic means you want x to be less than 1/5 or x is greater than 1. And that's it. That's your answer. You'll note that I did not need to rely on any previous work. I didn't need to split into cases. I didn't need to worry about whether the absolute value was positive or negative, or need to worry about drawing out the graph. They are helpful and useful tools to have to give you an idea of what's going on, but the question can be done direct, quickly, and cleanly without any of that. And that's how I would suggest you do this question.